I'd like to welcome Gurion to talk to you this morning. Okay. So I'm going to move around a little bit. I have never been in a room filled with this many women. I think the sex ratio for the teaching profession is incredibly biased. So this morning you might find my talk a bit of a mishmash of different things, and that's because I basically picked a few things that I wanted to share with you. But my story doesn't begin in a lab, it doesn't begin in the field, it begins at the dinner table. And very shortly, as you're being served now with your platter of food, some of you might recall a scene from your childhood where mom and dad presents a plate in front of you and says, "Child, eat your vegetables." The scene looks something a bit like this, if you recall. And there in the center of this little boy's plate is arguably the world's least favorite vegetable. That is broccoli. You're most certainly familiar with that. Having said that, broccoli is the #1 vegetable that gets sold in Coles, by the way. So it must be quite popular here. Broccoli, however, and you might not know this, is actually a cabbage. It is one of many cabbages. And all of these are various varieties of cabbages. From the top, you have things like the European, green and red cabbages. Cauliflower is also a cabbage. There in the center, you've got Brussels sprouts, that's how they grow, and Chinese varieties of cabbages. Wombok, bok choy, these are very popular in Australia. There at the bottom, those pretty looking things, those are ornamental varieties of cabbages, which are edible, but more than anything, they are used for, as pretty plants. And there at the bottom right corner is a superfood. Does anybody know what that is? That is kale, and kale is also a cabbage. This is a Big Mac. And look at all that goodness, hey. And there, sandwiched between the patty and the bun is lettuce. Now lettuce is not a cabbage, but all of your favorite fast food is deep fried in what? Oil. What kind of oil? Well, vegetable oil. And when I tell my students this, they say olive oil. I wish we could afford that. But no, it's, all of your fast food is cooked in vegetable oil. And what kind of vegetable does anybody know? Canola, exactly. And canola is also a cabbage. And here in Australia, you have what can only be described as fields of gold. There we are. This is a canola field. I want to introduce you now to another parent that also wanted their children to eat their vegetables. This is the cabbage white butterfly. And as the name suggests, throughout the year, these things locate cabbages and lay their eggs on the cabbages. All of these eggs hatch into tiny caterpillars with a voracious appetite for the greenery around them. Okay, they work as a team and they can defoliate the plant quite quickly. So you can imagine if you were a grower of cabbages, that the one thing you probably want to do is get rid of them as quickly as you can. And what do? Conventionally, we spray them with pesticides to protect the crops that we eat. I, however, have a better solution. What we could possibly do is to combat insects that we dislike with insects that we like. So combating insects with other insects. Here, lurking mysteriously amongst the greenery is a rather innocent-looking wasp. I know it's a bit grotesque for breakfast, but bear with me. She is on the lookout for caterpillars, and when she does find one, with surgical precision, she is injecting her eggs inside the caterpillar, leaving behind merely a fleshy wound. Now, by the time the caterpillar is fully grown, it's about 600 times the size it started out life with. And of course, all of you are teachers, and you know the next stage in the caterpillar's life cycle is the pupil stage, okay? And you guys know the technical term. Students always say, cocoon or chrysalis. But here in the safety of a pupa is when the animal's body breaks down and reassembles into an adult. Now these are the unfortunate ones that got attacked by the wasp. Outside of these, what's happened here is that these are baby wasps, and they're basically bursting out of the side of the caterpillar. They've killed the caterpillar now. Caterpillar doesn't make it to adulthood, and these things form the next generation of wasps that continue this rather vicious cycle. So I'm an entomologist, as I've been introduced, and this is a really inaccurate representation of me. I am not this loony all the time, but I do specialize in a group of insects, the butterflies, the moths, which are essentially the same thing, and also some wasps. So I work with biological control agents, and I know all of you are going, oh, cane toad, Okay, but we might talk a little bit about that later on. Because of the work I do, there is an agricultural slant, and a lot of the things I do actually get exported overseas to be experimented on. And a lot of work I do happens in the Pacific region, in Samoa, Fiji, Tonga, and the Solomon Islands. A lot of growers there are small, what we call small stakeholder farmers, which means that they're just a family operation. They grow very little, they supply very little, and they don't have the money to afford chemicals to spray on their plants. So they are very, very keen on biological control of insect pests. Okay, so that's something that we do there. Now, if you do find me familiar, that's possibly because you've seen me on Gardening Australia. And on that program is when I introduced to the broad public what are some ways in which you can control insects in your backyard. Hopefully you don't find me familiar, because if you're watching Gardening Australia, most of you haven't reached that age group yet. Okay? Some of you are past it, unfortunately. Age is just a number. Okay. There are several challenges that we face at the university when we're teaching entomology, and these are challenges on top of teaching itself. And so I want to share with you 3 of these challenges and how we are looking at developing ideas in which we can probably try and inspire young minds to take up entomology. The first thing you'll notice is that in no university, and this is not just a phenomenon in Australia, no university offers an entomology course. They don't offer programs which are purely entomology based, and this can be quite a valuable asset to have if you're an entomologist. So the first challenge that I was given, if my remote will work, there we are. So the middle child often gets left out. Some of you are middle child and you'll know this, and I'm referring in particular to middle school, so years 7 and 9. We have very robust programs for the graduating cohort from high school, so years 10 to 12. We have a very robust program when it comes to entomology and integrating entomology into outreach workshops that we do with them. But I've been challenged with developing something for years 7 to 9. And here I'm going to introduce you a program that will soon be launched, and hopefully you can get some ideas from this. If you're based in Queensland, you're quite fortunate that this program will come to you. But if you're not, then some of these ideas here, I'm happy for you to explore them independently. And if you need to have a chat with me, please feel free to do so. And this is a workshop called Mapping the Butterflies. And in Australia, we have some of the most diverse, variety of butterflies. And because we live in all sorts of environments, so there's quite a diversity of them. And in this workshop, what students are going to do is get exposed to, they don't have to get into too much detail as to, this butterfly is this butterfly is that, but just an appreciation of the different types of butterflies, and then ask certain questions about who is related to who. And what they can do, you can see in this photo, look at how excited these students are. They must be really enjoying themselves. But basically, they have access to actual specimens where they can have a close look at and compare them. And look at different features. They can choose to look at color, they can choose to look at body size. These are just a few things that they can choose to look at. And based on that, start matching those that are quite similar. So in this case, this student has found 2 butterflies here. And he's matched them because they both sort of have the same coloration and possibly the same sort of wing shape, okay? And so one might hypothesize that in the tree of life, these 2 species of butterflies are quite related to each other. And by pinning the different butterflies together, they can develop different phylogenies. And they can try and put together who is more related to who in a very basic phylogenetic tree. And this is something that I think students don't have a good grasp on, and that's understanding the diversity of life and why it is important that we start categorizing them in this way. So in this case, the student has put 2 of the orange ones together, and he's gone based on color, and then 2 of the darker ones together, and suggests that they are evolutionarily separated from each other in this respect. Now, another student can go one step further and choose to do something completely different. They might have a look at, as we all know, butterflies, go through several life stages. He might choose to look at the caterpillars. And if you have a look at the caterpillars, these are all milkweed butterflies. If you have a look at the caterpillars, they all look slightly different. They're all stripy, but they all look slightly different. And one, if you're able to scrutinize the photos, you might be able to see on the caterpillars some of these tentacles. We call them tentacles, and these are just basically accessory tissues that are used for defense. So if a bird comes and tries to pick it off, they'll probably pick one of these tentacles at the expense, and the caterpillar is basically spared. And a student might then reorganize the phylogenetic tree based on how the caterpillars look like, and might come up with something completely different. So what we're trying to get at is there's no right or wrong answer when we piece the phylogenetic tree together. What we try and do is really get an inquiry going with the student to ensure that they're asking themselves the question and validating their hypotheses. If they choose to decide to pair something together, is this a meaningful comparison to make? And that's what we're trying to get. Again, there's no right or wrong answer. And one thing we want them to do is try and appreciate that phylogenetic trees come in many shapes and many forms. And they can be as creative as this. Of course, a student wouldn't be able to produce that. But this is essentially the phylogenetic tree of Australian butterflies. Okay, and it's something that they can appreciate, the diversity and how we categorize them into groups. Now, you might be wondering why any of this is important and where the student will see the value in categorizing them into phylogenetic trees. If we have a look at this group here, the Danaians, which are the milkweed butterflies that you saw earlier on, all of these are specialist feeders of milkweeds, which are a pest plant. Okay? So you can imagine that as environments change, pest plants are more likely to persist, and we're probably more likely to see an outburst of milkweed butterflies, which, for those of you in Queensland, if you remember last year, we had one of the most spectacular outbursts of blue tiger butterflies. They were literally flying across the highways in tens of thousands of them. And if you recall that phenomenon, that is purely because we had, again, an outburst of weeds, which are the milkweed. If we look at a different group here, these are the same groups which the Cairns birdwing butterfly is a member of. They feed exclusively on one vine. So you can imagine that as habitat changes go, when we urbanize different areas, we are clearing land and we are losing a lot of vegetation, and that may include precious vines that only this species relies on. So the whole idea of grouping them into phylogenies is that phylogenies are very meaningful, and we want the students to get that we can tell a lot more. It's not just about who's more related to who. We can tell a lot about their life cycle, their life history, what is it they eat, and there are conservation consequences for that. And that's what we're trying to get at the middle school level. A second challenge is that transition from high school to university. Okay? And a lot of, we live in a digital age now, and there are a lot of students with different learning abilities, and how is it that we try and accommodate all of them? So the next two challenges are two stories that I'm going to share with you, which are two prominent biology courses at the University of Queensland, and some of the initiatives that we've done to improve the way in which we teach first-year biology. And hopefully it gives you some idea of that universities are no longer that very conventional, traditional form of I lecture you, you listen to me. It's starting to become a lot more interactive, and hopefully the students and the teachers can appreciate that. Welcome to a scene in one of our biology courses. This is Bio 1020, Gene, Cells and Evolution, and it is a course where the students are basically exposed to the theories of evolution in cell biology. This is one of the tutorial classes that you're looking at, and this is a course that services about over 1,000 students in most semesters. One big issue we have with servicing 1,000 over students is the fact that they are incredibly diverse. We've got medical students, we've got chemistry students, math students, physics students, and we even have arts students that are doing this course as an elective. So to accommodate everyone, we've had to change our teaching style radically. This is one of the theories they're learning in this class, and that's the Hardy-Weinberg genotype equation, which is an equation for those mathematicians amongst you. This will be very familiar. It's a perfect square equation. And this is an equation in which we can use to various populations of animals and determine dominant and recessive traits and how they manifest themselves in a population. So the three terms, the p squared, the pq term, and the q squared term, are all directly related to different combinations of alleles. As you know, for the different traits that we exhibit, they are all determined by the alleles carried in our genes. If you've got two capital alleles, that means there are two dominant genes that have been paired together, so on and so forth. And the little a is a recessive gene. And this equation basically gives you an estimate on how these genes manifest themselves in a population. Okay? And if you do your math, you would come to the idea that you should have about this sort of arrangement, where 75% of them on the left side will exhibit a dominant trait, and then there will be a 25% which exhibit a recessive trait. How have we taught this concept to students? Well, we've done something a bit different and a bit cheap too. We've used paper clips. If my pointer will work. We've used paper clips. And what we've done is we have, I know what you're thinking, because alleles need to come from both parents, a dad and a mom. Yes? And you can see the paper clips are blue and pink. They don't actually represent dad and mom, because at university we don't conform to gender stereotypes. Okay? The pink and the blue represent different alleles, dominant and recessive. Okay, so blue for dominant, pink for recessive. Okay, that's a gender stereotype. This is even worse, isn't it? It's subtle, it's very subtle. Okay? Yeah, if you got it, that's good. Okay. And the different shapes, the spiral and the normal paper clips, they represent the parents. Now, essentially what the student needs to do is start pairing them off, and they can pair them off quite randomly. Okay? And hopefully, at the end of the pairing, they will come to the same 25 to 50 to 25 ratio of different alleles, okay? And they do that. Something we do have at university are glass top tables, which means that they can write on them as well. So that's something that we do have. So you can see that this group has basically put, the different groups aside, and they've come up with that kind of ratio that we're expecting. Okay, and this group has gone one step further and found a mutant gene as well. So this is just some of the creative ways. Where does entomology come in all of this? Well, it comes in the exam. This is an exam question. It's translated to assessment. And you can see, so within a population of grasshoppers, we've got two genes. Green is more dominant over yellow. And we basically expect them to derive the formula and calculate the ratios based on the information given to them in this question. The third and final challenge relates to how we move from laboratory to field. It's really difficult for us to teach biology unless we take the students out into the field. It's where they really get their hands-on learning. But with the first year course, with over 600 students, which is the course I'm about to share with you, that's a real main task to coordinate. But we do that, okay? So I'm going to share with you one of our experiences. But before that, I have a story to tell you. Welcome to the Hunter Valley, okay? I do a bit of work in this particular project. This is a very misleading photo because this is taken from a tourism brochure. Come to the Hunter Valley, picturesque and beautiful. You all know what the Hunter Valley is famous for? For wine, exactly. Okay, so lots and lots of vineyards, lots and lots of wineries, and come to the Hunter Valley. It's going to be wonderful. But in reality, the Hunter Valley is something like this. It is very dry, and you have to. The reason why I'm in that particular pose is because of the sheer number of flies that will irritate you the whole trip. Another thing that you might not know the Hunter Valley to be famous for is, if I can get this to work now, come on. The screen just wants so much of me. Okay. It's the breeding of thoroughbred horses for the racing industry. Everybody knows who this beautiful beast is? This is Black Caviar. She's famous for 25 consecutive #1 wins. I'm about to show you some rather grotesque photos, so bear with me. If you can't accept them, then make sure you swallow now. Swallow your food now before I show you them. Now, in 2004 is the first case that was reported of this condition. The mare, the female horse, runs a fever, bloodshot eyes, occasional nosebleed, followed by an abortion of the foal. And you can see that the foal, when it does get aborted, some of them are aborted at quite advanced stages of development. Okay, and of course, if you lose the foal on the odd occasion, you also lose the mare. I obviously don't wish this on any of you, but does anybody know the main reason why you would abort a child? Yeah, the most common reason is infection of the placenta, or infection of the womb. And this is all leading up to this abortion. The only way to get an infection is to get a cut, to get an open wound of some sort, and the bacteria can fester. And in a horse's anatomy, the digestive gut, the digestive system is very close to the placental lining. So what's actually happened is that we've found a lot of these spines that basically get lodged in the gut, through the gut, and then through to the placental lining, causing the rupture, the bacterial infection, the fever, and then followed by the abortion. Not many horses actually abort their foal in a breeding season. You're looking at about 40 cases per year, but with so much money invested per horse, you know, that is a cause for concern. Now, what are these spines from, or where are these spines from? Does anybody want to make a guess? Bearing in mind that I'm an entomologist. Yeah.
When they're actually eating, they're taking in some sort of part of an insect?
Yeah, exactly. So they pick it up in the pastures. And these spines belong to these caterpillars. I probably need to change the battery on this. These caterpillars. This is not one caterpillar. This is a train of them. They're following each other. We call them processionary caterpillars, and that's because they follow each other. And as you might know, these all insects shed to grow. They mold their exoskeleton. And these things actually form large nests under trees, or sometimes in trees, and they shed a lot of their spines. These spines get blown with the wind onto the pastures, and the horses pick it up in the pastures, and that's how they're getting ill. So hopefully you can appreciate just how far an entomologist can go. I never expected to go this far with the work that I do, but it gives you an appreciation of just how interesting and intricate the different interactions between species can be. And that is, the interaction between species is the fundamental concept that we want to take across in this next first year biology course that I want to talk to you about. And that is Bio 1030, Global Challenges in Biology. In this course, we want students to have a look at the different interactions that they can see in the natural world and how these interactions are responsible for the services that the ecosystems provide us. Things like pollination provide us a wonderful ecosystem service. And that's what we cover in this particular course. And so in this course, we actually take our students to the field. We've got 600 over first-year students, and like I said, it's a huge task, but this is not something that you can't do as a teacher. You can most certainly take a small group, and I'm about to share with you what some of the things we do on that field trip are. So the student basically gets taken to Brisbane Forest Park. This is a really interesting ecosystem because it's what we call an ecotone. And an ecotone is where two different distinct environments start to transition from one to the other. And we've got basically rainforest going into sclerophyll forest, and the students can appreciate that transition of environments and the different interactions that the different environments hold. And the picture on the right is just basically a group discussion that some of these students are having. And one of the concepts, for example, that we teach in the lectures is the concept of predation. And we basically ask these students to go on a photo hunt. Go into the field and find a photo, take a photo of predation or evidence of predation. When you say predation, you automatically think you are in the Serengeti and this is the lion chasing the zebra. There's the first thing that will pop up to your head. But predation can come in many forms because predation is simply the consumption of one species by another species. And based on that definition, a student can most certainly go out and take a picture of a plant that's been eaten, because that is predation. That is evidence for predation because it's one species consuming another species. Okay? So we actually get our students to take photos of the concepts they've learned in class during this field trip. and they get assessed on the quality and the way they can argue why their photo is an example of predation, for example. And of course, it's a list of over 40 things that we expect them to take photos of, and very rarely do they get all 40. What you might notice, does anybody know what plant this is? This is on the side note. Anybody know what plant this is? Yeah, this is a ginger. And what you might notice is the most nicely circular cutouts from each of the leaves. No living herbivore actually eats like that. Okay, a nice, perfect circular cutout. These are actually done by leaf cutter bees. And they don't actually eat the leaves, they actually use the leaves to make nests. And so, you know, in that particular restaurant, we don't expect the student to know all of this, but you know, should he or she have taken a photo of a leaf with some damage on it, yeah, that's predation, and we'll accept that. Okay, but that's a side note. So some of the photo, this has been published. Exactly what we do on the field trip has been published. So feel free to get in touch with me. I can send you this paper, and it'll give you some ideas of what you can do if you wanted to create your own field trip for your students. Okay, and it goes through that particular paper basically outlines all of that. These are some of the photos that have been taken by the students. So different things, like we asked them to look for a decomposer. So if they found, say, a slug, then that would be a decomposer. We asked them to look for a form of animal defense. These spines on the caterpillar are a form of animal defense. And more challenging than anything, we asked them to find a photo of 6 ecological processes in the same frame. And some students take a photo of that because in that photo you see disturbance, somebody has cut down the tree. You see things like succession, there are things growing over this log. We see things like decomposition. So there are different processes that if you look hard enough, you can actually find lots of things happening in the same frame. Okay? Otherwise, I will leave you there. I hope you've enjoyed my short stories. I know it's a mishmash of different things, but hopefully it gets your creative juices flowing. I am available to take some questions at the end, and if you'd like to have a chat, please feel free to do so. I'll just remind you that, you know, feel free to have a look at our specimens that I've brought for you today, but please don't take them home with you, because the second year zoology students will have nothing to look at next semester otherwise. I'll leave you there, but I want to just leave you with some contact details. If you are interested with any of the programs or any of the opportunities that the University of Queensland can offer, particularly if you're a school based here in Queensland, then these are some of the people that you can get in touch with. The Faculty of Science is there on the left, and what the Office of Prospective Students do are they are the ones that hold all the school tours. If you want to come and visit UQ, they are the people to contact, and they can arrange a program for your school. Otherwise, for those of you who are in Queensland, I also want to invite you to our open day at St. Lucia on the 7th of August. That's on a Sunday. If anything, come for the free candy floss. And one thing that I'm going to do on open day is I'm going to talk to basically the public and anyone who's attending open day about how you can pursue biology at the university level. But we're also going to have a really interesting activity which we've titled, Who Killed Justin Bieber? And it is basically a forensic science activity with biology principles. So if you're interested, a lot of those activities are also things you can take back with you, and you can most certainly easily find the resources on your own to execute those activities in your classroom. Okay, so with that, thank you very much for having me. I hope you've enjoyed this morning, and I'll leave you with it. Sarah, back to you.